In topic 3, we're going on to what is called the conditional statement. And some of you may be familiar with this, but basically it centers around the word if something, then something. In our way of illustrating it here, if P, then Q. And the P, or the if part of your statement, is referred to as the antecedent, and that's what comes before, and then Q would be the consequent. So let's look through this, and they have some of these down below. If I read too long, then I get tired. If looks could kill, then I would be dead. If he doesn't get back soon, then you should go look for him. So these are all what we call conditional statements. Often, in short, as we mentioned before, an if-then statement. So again, you can read this over, but it does state the way to symbolize it. P implies or yields Q. Again, if P, then Q. And there's the word antecedent and consequent. Now, we'll be going over this, and you'll be asked to form various conditional statements. Sometimes you don't see the if and then, but you would write it if they asked you to put it in. For instance, quitters never win. You would put the if in there. If you're a quitter, then you will never win. So we can modify a statement sometimes to put it in the if-then form, and I'm sure they're going to be asking you to do that. Now, sometimes they can be reversed. In this example, if it is difficult to study when you are distracted. This can be reversed into if you are distracted, then it is difficult to study. So we can modify statements to put them in the conditional form. In this next one, if you aim at nothing, you will hit it every time. All right, that's kind of a play on words. So if is there, you could put the then in there and make it a conditional statement in the form if then. All right. If you fail to make your payment on time, then your car will be taken. Again, modifying what they're saying here. So we can put that in the conditional symbolic form, where we're going to let P represent if you fail to make your payment on time, and let Q represent then your car will be taken. And from this, there are 4 combinations of truth values for the 2 component statements. So let's analyze this truth table. Possibility 1. Failed to pay on time, yes. Car taken, yes. So P is true, Q is true. Failed to pay on time, yes. Car taken, no. Here P is true. The consequent is false. Failed to pay on time, no. Car taken, that would be P is F, where Q is true. Failed to pay on time, no. Car taken, no. P is false, Q is false. So in a sense, a truth table. So let's look at this in more detail. Now I went over this a little quickly before, but we need to see the scenario in which this was set up. That you imagine you bought a used car with financing from the car dealer, and the used car dealer salesman says, if you fail to make your payment on time, then your car will be taken. So here we're going to let P be the antecedent. If you fail to make your payment on time, then Q, your car will be taken. And they're also mentioning that the four combination of truth values for the two component statements that we've gone over are well defined here, and you'd need to read these over. So let's pause. So here, again, we assume you failed to make your first payment and your car was taken. So P is true. Now keep in mind, we do not claim that your car was taken because you failed to pay on time. It might have been taken for some other reason, or it might have been stolen. All right, in example 2, the second case assumes that you failed to make your payment on time and your car was not taken. Maybe they couldn't find it. So the salesman may have lied about saying that it would be taken. So place an F in the second row of the truth table. In the third case, you assume that you paid on time, but your car was taken anyway. So, and you're thinking maybe the salesman did not lie, but you don't know what happened. Maybe it was stolen. Okay, so you would place a T in the third row of the truth table. Finally, assume that you made a timely payment and your car was not taken. This certainly does not contradict the salesman's statement, so place a T in the last row of the truth table. Again, you may have to read this over, but it is a little complicated. So what I've done is made a little copy of this truth table for the conditional, P, then Q. So if they're both true, true. If this is false, false. If this is false, but Q is true, it's true. And if they're both false, that is true. The only time it's false is when your antecedent is true and your consequent is false. Now, another important thing here to note is in no way does the statements imply a cause and effect relationship. Consider the following. If I pass math, then the sun will rise. Well, passing math is a possibility, and we know the sun will rise, whether this is true or not. Okay. Now again, as we do examples, it's sometimes useful not to look at the answer first, but to try it based on what we know. Well, if P, Q, and R are all false, then what I've done here is P is false, yields not false, so that would be true, yields not false, so that would be true, and Q is false. Now if we look at our truth table for the conditional, if we have false, true, false yields true, that is true. And if we have true yields false, that is false from our table. And then we end up with true yields false, and according to the little table I'm holding in my hand, that indicates false. Now, I don't know if you're going to memorize this or not. I might be able to in the future, but I'm using my little index card in which I've written the truth table. Now, some other little special characteristics of conditional statements would be P yields Q is false only when the antecedent, that is the P, is true and the consequent is false. So that's the only time it's true. If the antecedent is false, then P yields Q is automatically true. And if the consequent is true, then P yields Q is automatically true. So again, a little summary of that little chart. So let's go on. So with my little index card in hand, let's look at what we have here. Now we're saying P here yields Q for all of these, and we say this is true, but it's going to yield, does 7 equal 3? No. So that would be true yields false, and on our little chart, that is false. So in example B, as we look at our P statement here, 8 is less than 2. Is that true? No, that's false. And our Q statement is false. So we have false equals false, or false yields false. And if we look at our truth table for the conditional, this then is a true statement. And let's go on to letter C. Here we have 4, and this would be our P statement, does not equal 3 plus 1. Well, this is actually true, but the way it's written here is false. So false yields Q, which we're saying is true. And again, looking at our truth table, false yields true is true. Keep in mind that if this is your truth table for the conditional here, then negating each of these, not P, not Q, would be the opposite signs here, and then the negation yielding the negation, or implies the negation, then these are the values that you would get. Notice in the original, these are the only two that are switched around. And as they go on, they get a little more complicated. keeping in mind, as long as you can read it, not P, and this symbol, the caret, is and, NQ. Remember here they must both be true, and they're giving this value, and then negating both of these, and we're saying it yields this. Again, this is still N, and could also be this way, and then going on. Now notice for B, we're changing from and over here to or, the inverted caret symbol, and these are all true. So we'll see how in depth we're going to go into this, and we will continue. And as we mentioned above, with all of these statements true, it says that no matter what the truth values of the components, such statements is called tautology. And these can be checked by forming truth tables. Now I made up another index card, putting this table in, where this is writing conditionals as a disjunction. And you might say, well, what's the difference? Well, these others were and. Those were the conjunctions that we did previously. The disjunction will be an or. And here is the consequence of that. So notice our symbol is the inverted caret, and these are true according to what is listed in the truth table. And we see it all listed there. So let's do some practice now in writing conditionals as disjunctions. So the initial conjunction, the conditional statement, is equivalent, and remember for equivalent we can put the 3 lines there, to this. Not P, and this symbol or Q. So again, when we think disjunction, the word or the symbol inverted caret. And see if we can follow this. This is the disjunction form. Now if we put this in parentheses and this in parentheses, the negation of this is equivalent to the negation of that, which is what this next line indicates. And if we apply De Morgan's law to the right side, the equivalence gives the negation as a conjunction, where we're switching from an or here to an and. And again, I'm sure thankful that we can use our notes when we're asked to do homework and later test, because there's a lot to remember, and you would get lost in the trivia of this. Now, as we look at the negation of a statement, if I'm not hungry, this will be P. I will eat. This will be Q will be I will eat. So we have P yields Q. Now to negate this, we're going to go P yields not Q. So how would I say that? Well, if I'm hungry, I will not eat. And of course they have the answer here. Now in looking at part B, all dogs have fleas. This is a generalized statement. So we would have to put it first into an if-then form. If you are a dog, then you have fleas. So this would be P, and this would be Q in its conditional form. Now to negate Q, and they say it right here, if it is a dog, then it does not have fleas, would be the negation. And again, you're going from symbolism into something you can actually see and know about, which I think is very useful. So in letter A, they want us to write equivalent to the conditional. And we know that this is equivalent to this. So this will be our P, then this will be our Q. So without the if and the then, we're going to say the Indians do not win the pennant is the negation of P, or not P. And then we use the word or for the inverted caret. Johnny will go to the World Series. And we could look at the second one too. If it's Borden's, it's got to be good. I haven't heard that for many, many years. That used to be a very famous, it was ice cream, Borden's ice cream, I believe. So P represents the Borden's, it's got to be good, is our Q statement. And it's got to be good can be restated as the negation. It's not Borden's, and again, or the inverted caret, it's got to be good. So sometimes these don't make sense, but at least it's better than just symbolism all the time. Now in the study of circuits, and this is in electricity, and I remembered when I taught general science years ago, we would do some circuits. This is a series circuits when they're one after another, and these were parallel circuits where the electricity could go this way or this way. Here they had to go in a straight line. So the general form of this is either the circuit is open or the circuit is closed. So some of the background is written here. And when you have a single series circuit like this, in order for it to work, they all have to be closed. So these are AND or conjunctions. In a parallel circuit, if one is open and one is closed, it would still work. So these are disjunctions, these are ORs. And they give you the symbolism of this. Here when it's in series we're using the caret, which is the and. When they're in parallel, they're using the V, the inverted caret, and then we can draw some of the things here. So they are using the equivalent statements of symbolism to simplify circuits. Remember, when it's closed, it functions. When it's open, it doesn't. So open is false, closed is true. And they summarize this here. Now, the authors of our text give a very good video on this, and I think that we will be showing that video as part of this lesson. He does a nice job. And I'll give it a shot here as well. So here we see these are parallel currents here. So to get the switches to work, to get this side to work, both must be down. So we have to have P and Q work there. Put that in parentheses if we'd like. And to get this one to work, we would need P and R. Now, if one of these is true, then we're in good shape. So we can then say or as a combination of these two. So this is where we are. We can make the circuit more efficient by cutting out these two possibilities and just put the single P there, which is what we're indicating here. But then now it's going to be and this combination, which is also an or now, because one of these can work and the circuit will go on. Another way in drawing this one, they ask you to draw the circuit, look at it carefully, and see that in a sense this is represented by this here. To find it, you'd have to go back to your equivalent statements, where P yields Q is equivalent to not P or Q. And that's what they're showing here. Okay, when will I ever use this? Well, your textbook does give you how we're going to control, using our cell phones, various systems within our house. And apparently that can be tied in, but we're not going to go there. Now we're going to spend a little time on some exercises. I'm going to show you that video because I think that would be useful if you haven't watched it already, or review if you have. So we'll be looking at our textbook and some of these, and we'll be asking for responses. So let's wind this up.